In this unit, we're going to talk about ecosystems. An ecosystem describes the interconnection that scientists witness between living organisms in a system. As we approach solutions to the great unraveling, we need to become systems thinkers. We need to become systems designers. And the first step is for us to understand the basics of a system. One thing about ecosystems is that they run on cycles. Nature constructs her systems such that they are cyclical systems. One thing goes back to another. We'll examine some of these cycles as we go through this unit, and we'll look at soil as a specific example. Now, what does soil have to do with the enormous problems we've been talking about in this course? Well, Jeff Lawton, one of the big names in the permaculture movement, says all the problems of the world can be solved in a garden. Wait a minute, is that true? Let's take a look. When I teach this in a classroom situation, we often play the string game. Perhaps you've played this with a group at some point. It's fairly simple. The group gets in a circle and you toss a ball of yarn back and forth. Each person hangs on to a bit of the string. The yarn becomes a visual example of a web of connection. Everything in an ecosystem is connected in some way, directly or indirectly, to everything else. The caterpillar in the garden is connected to the leaf, is connected to the tree, is connected to the bird, and the bird is connected to the soil, to the rain. Nature designs her systems so that everything is interconnected. And as we move forward with more sustainable design, we need to keep this concept in mind. First thing as we talk about soil is we call it soil, not dirt. Dirt sounds dirty, sounds dismissive, something that we don't want to be around. Soil, particularly living soil, is the foundation of all life on the planet. Plants grow in it, herbivores and omnivores gain their food from it, even carnivores depend on it. If it wasn't for the soil, we wouldn't have the plants for the herbivores and omnivores to eat. Soil across the planet is under threat. Arable land is one of the resources for which we're reaching peak. There isn't an unlimited supply. I saw John Jevons explain it this way. If we start with an apple, our whole apple represents the planet, our one small planet that we all share. Now think about this. We can't grow food on all of it. 3/4 of it is ocean. We need to set that aside. That leaves us with 1/4. Of that 1/4, 2/3 of that is deserts. It's uninhabitable and we can't use it for growing food. So this little small chunk in the orange box becomes our farmable land. Of that small chunk, we can cut away another 3/4 as depleted soil, soil which has been so overused or abused that it's no longer able to grow food. So this tiny little remainder, just 4% of our apple, is all that we have available to grow food for all of humanity. And as I write this, there's an estimated 7.6 billion of us. And what are we doing with this tiny little remainder? At this point in the demonstration, John Jevons opens his mouth and pops a little bit in and crunches on it. We're gobbling it up. We continue to abuse it, we continue to expose it to erosion, we continue to plow it, which breaks it open and exposes it to the elements. We continue to spray it with chemicals that take Mother Earth years to recover from. Now this diagram is quite old, but I haven't found another one quite like it. Back when this was calculated, in the United States, for every pound of food eaten, 6 pounds of farmable soil was lost. That might be to water erosion, to wind erosion, or to unusability due to chemical pollutants. In developing nations, that figure grows worse. For every pound of food eaten, 12 pounds of farmable soil was lost. In China at that time, 18 pounds of farmable soil were lost per pound of food eaten. Now I understand that the Chinese figure has gotten a lot better since this diagram was created. But the point is that When we pay attention to our farming practices, we can actually build soil instead of lose it. This is through regenerative practices, biointensive practices, sustainable practices, and other nuances of these. The way we treat our soil isn't just an agricultural issue. Our soils have tremendous capacity to help reduce global warming. The organic matter and the living element within our soils can actually capture carbon from the atmosphere and lock it into the soil. This is called soil sequestration, and we'll look at it deeper in the adaptation and mitigation unit. I mentioned the living portion of the soil. Realize that in a single teaspoon of healthy organic soil, we have mind-boggling amounts of living organisms. The one we're most familiar with is the earthworm, but this is only one representative of a wide diversity of living critters. But we're going to use the earthworm as a symbol of all of them. Their friends, and I use the gender-neutral pronoun because an earthworm has both kinds of reproductive parts, includes familiar organisms which you can see, like millipedes and ants and beetles. But it also includes tiny little things like springtails and mites, and things you can't see with the naked eye, like bacteria and fungi. All of these organisms work together to break down organic matter. When we say decay, we're talking about these organisms feeding on the dry leaves or whatever is in that pile in order to break it down into tiny parts which become bioavailable to the roots of the plants. Bianca Levy's put together a fantastic children's book called Compost Critters. She took her camera out to her compost pile, slapped on a special lens, and dove into the pile to see what she could find. Again, our larger organisms are things like earthworms and the roly-polies or sow bugs. You can see how small they are in comparison with something that looks like pumpkin seeds. This marvelous orange thing is probably a slime mold, another life form which feeds on the decaying matter. And with these fine threads, we get to the heart of the matter. These are delicate threads of fungus, the mycorrhizal fungus, which you will hear so much about if you explore current-day organic gardening or soil science. The mycorrhizal fungus works in concert with the roots of the plants. The mycorrhizal fungus channels the nutrients to the plants in exchange for sugars that the plants produce. This is the heart of the system of functioning organic soil. Now, what do you think happens to our earthworm and all their friends if we, just this once, use a little weed killer or any of those other brightly colored packages from Home Depot? It kills them, of course. It sears them out of existence. It fractures Mother Nature's efficient working ecosystem and leaves it broken and non-functional. At that point, the beetles and the springtails and the earthworms aren't breaking down the organic matter anymore, so it's no longer available in the soil for the mycorrhizal fungus to channel it to the root hairs of the plants. Your plants will starve. In order to make the plants grow, you'll have to apply chemical fertilizers. And what do the chemical fertilizers do? Any soil organisms that were trying to reestablish their population, it wipes those out all over again. So then, when we're engaging in chemical gardening or chemical-based agriculture, we have a missing or severely depleted ecosystem of natural soil organisms. We hear from indigenous elders that peoples have treated the earth and her soils as living beings for thousands of years. Now scientists are beginning to catch up. The soil, or shall we say healthy organic soil, is a living, functioning ecosystem. When we handicap that functioning system, our plants can't grow healthy food for us, and soil sequestration falls apart as well. Soil sequestration, the process of capturing carbon from the atmosphere and locking it in the soil. But who does the work? The living component of the soil. The living organisms break down organic matter, which is then resident in the soil. When we use chemical-based agriculture, which disrupts or kills the living soil organisms, that avenue is closed to us. So let's look at a really simplistic example of a system, a compost cycle. I've been referring to that organic matter in the soil. Well, where does it come from? Well, when you get your bundle of carrots from farmers markets, they've got tops on them. You cut the tops off, and instead of throwing them to that mythical place called away, let's say we put them in our compost pile. Inside our composter, our living organisms do their happy work, and they break down those carrot tops into small particles. The result smells fresh and clean, kind of like the forest floor. This finished compost gets mixed into your garden soil. When you plant carrot seeds, you get little sprouts which then grow up and become carrot plants, and they start the cycle all over again. The cycle continues. Mother Nature designs in cycles. But do you spot the flaw in this cycle? There's a place where we're losing matter from this cycle. The carrot roots. The part we ate and didn't put into the composter. We ate the carrot roots and our poop did not go into the composter. That's a loss from our system. Over time, the system in our little example will deteriorate. It will function less and less well. The law of the return says that as you remove from the cycle, you must replenish the cycle. We need to add something back in order to replace the missing carrot roots. Now, the compost cycle is just one highly simplified example of one of Mother Nature's systems, but she has plenty. Here's the water cycle. The sun shines down on the oceans, the water evaporates and becomes clouds. The clouds move in over the mountains and become rain. The rainwater flows down the rivers back to the oceans, and the cycle begins all over again and again. Mother Nature has a carbon cycle as well. It's a bit more complicated than our simple explanations, but suffice to say that in normal conditions, nature can take care of the carbon produced by animals. She can balance it with plant respiration, and everything remains fine. It's when humans start burning fossil fuels that we begin to have severe disruptions in the carbon cycle. Industrial systems designed for current-day economics tend to be linear systems rather than cycles. Our typical linear system, often called an extractive system, extracts raw materials from the earth, transports them, often to another continent, for manufacture into a product, which is then shipped, often to yet another continent, to be used. If it's a single-use item, or an item with planned obsolescence, it's very quickly thrown away, which means it's shipped off to a landfill. We use the euphemism disposable, but what this process really means is take from the earth, use it once, and throw it away. It's a unidirectional flow. Where is this place called away? It's mythology, because there really isn't an away. There's a destination there at the end of the line. Usually, it's an enormous, stinky, plastic-lined pit in some far-off area on the edges of our city, often in a neighborhood where the people are too poor to hire attorneys to keep it out of their neighborhood. It's lined with plastic because all the things that exude from this massive pile of trash are toxic to soils and water, so they try to minimize that. They line the pit. In the United States, we're running out of landfill space, and resource managers are desperate to solve the problem. That's why there's state and local government pressure to do recycling programs and composting programs. They call these diversion programs, which basically means we are diverting that waste from going into a landfill. That's the objective. Putting this in the context of the Great Unraveling, these linear systems or extractive systems are a huge factor in our disproportionate eco-footprint. A healthy system is a circular system. A healthy system is a cycle. The debris or poop from one organism becomes food for another organism. Matter travels in cycles. It has to go somewhere, and in a productive system, it continues on in a form used by more and more organisms. Humans have developed broken cycles in our physical world and in our human relationships. Our economy is a profound example of a broken system. Returning to our definition of an ecosystem, humans are organisms, and we too need to work in concert with our environment, functioning as an ecological unit. In other units of this course, we're going to look at healthy human interactions, ways we can create healthy human cycles. These closed-loop cycles are the path forward in sustainable design.